Let's start our study of probability with the definition of probability. Probability is the likelihood or chance that something is the case or will happen. So when we say something is the case, that means it's already happened, we're just studying it. So for example, the Apple Store might receive a shipment of iPads. So the number of defects in that shipment is done. It's not something that's going to happen. It's sitting there, it's done. But we might consider the probability that one or fewer, 1 or 0, of the iPads are defective. It's already happened. We're just talking about the probability of once we open that box, we might find 1 or 0 defective iPads in that box. The probability that something will happen is probably more what you think of when you think of something in the future or predicting things like weather or whatever. But the probability, an example of this might be the probability that the S&P 500 index would decrease based on a change in interest rates. So the interest rates haven't changed yet, but we might study the probability of what might happen if that happened. What's the probability of a decrease, or what would that be? Okay, so we want to think about some areas where probability is used. And just a few are here. I mentioned weather prediction, traffic monitoring. Where's the best place to set up the monitoring for speeding or running a red light, that sort of thing. Health assessments, the probability after you study, get the information on a person, what's their probability of heart disease, for example. Of course, predicting sports. Somebody's always predicting, who's going to win the Super Bowl. They study things and use the methods of probability. Likewise, in politics, they're constantly taking polls to determine who might win an election based on the probability that certain people will vote a certain way. And certainly in business, all kinds of manufacturing, a paint manufacturer might need to know the probability that his cans are filling to, exactly a gallon or within a certain target, or that sort of thing. So certainly many applications in business. So how is probability related to statistics? Well, what we see is that probability is the basis for inferential statistics. So we start with our descriptive statistics, where we select a sample properly from our population, and then we study some characteristics of that sample: the mean, standard deviation, variance, range, all these things we've talked about before, 5-number summary. And then we would take that information and apply some probability theory to it, which leads us to our inferential statistics that we'll be getting to later in the course. Inferential statistics uses those sample statistics, for example, a sample mean, to estimate or make an inference about a population parameter. So 3 of the sample statistics we're going to be discussing are considered to be unbiased estimators. Okay, so these unbiased estimators for inferential statistics are, and let's write these up. So we'll have the mean, and so we have a sample statistic, the symbol for that, and we have a population parameter. Oops, let's fix that. And we'll write the symbol for that. So the mean is one of our unbiased estimators. What that means is that it targets the population parameter. Since most of the time it's impossible to know the population mean, we want to have the best estimator of the population mean, and it turns out the mean is a very good estimator of the population parameter for the mean. So for the sample statistic, the symbol is x bar, and for the population parameter, the symbol is mu. So we say that we use x bar to estimate, to target mu. So that's one, the mean. Then we have the variance. And the symbol for the statistic, the sample statistic, is S squared. It's the standard deviation squared. That's what the variance is. And the variance is one of our unbiased estimators. And we use S squared to estimate or make inferences about sigma squared, the population variance. And finally, the proportion. We haven't talked a lot about this one yet, but we will. Its symbol for the sample statistic, the sample proportion, is P, and we say P hat because it has this little hat on it, and we use that to estimate or target P. So these are the unbiased estimators. Now, we frequently use our standard deviation, we have the standard deviation is not in this list because it is not unbiased, but the bias is relatively small, and for that reason, when we have large samples, the bias is relatively small, and for that reason, we will be using S to target sigma. Okay? S isn't not unbiased, but the bias is relatively small. And the other advantage is the units of the standard deviation are the same as the units on the data. Not true for the variance, because if you have feet for your standard deviation, you have feet squared for your variance. So the units are not the same.